Andrew joined, and his company LastMile joined the AI Alliance a while back, and I think they were one of the first speakers at one of our first AI agent meetups, and we were very impressed, and we invited them to collaborate with us on a project that we're calling the Finance Deep Research Project, and it's based on the MCP Agent, and the project is really going well. We're very excited about it, and we wanted to give Andrew an opportunity to come and talk about MCP Agent and anything else we want to talk about. So Andrew, go ahead and take it away, and you've got up to a full hour.
Okay, perfect. Everyone can hear me right? Okay, right? Just want to make sure that it's working okay.
Yep.
Cool, okay, getting thumbs up. Awesome. So let me kind of set the agenda for, I guess, the next 53 minutes. I'll do a quick intro about myself, give you a bit of context on my background and how I got into this crazy world of agents, AI agents and all that. Then I'll talk a little bit about MCP Agent, an open source framework we have, and something that we've been giving to the open source community, getting a lot of interesting insights and building a lot of cool open source projects with. And then with that, we'll talk about deep research, which is that finance deep research use case. And we'll talk about our learnings. And so something that we found quite empowering was the fact that I think people have found that these AI novel solutions are becoming more valuable, which means less and less of this research is going out into the public. And we want to make sure that we talk more about it and make sure that it's more widely accessible to everyone, because it shouldn't be limited to just the largest companies in the world or these large model providers. It should actually be pretty widespread and used throughout so that we can push research further. And then I'll leave about 10 minutes, maybe 10 to 15 minutes at the end for any type of Q&A. Happy to answer any questions, talk about some of our learnings, as well as would love to just learn a little bit if others have gone through this journey as well. Amazing. A little bit about myself. Co-founded the company LastMile AI about 2.5 years ago. We used to be a team at Facebook altogether, Facebook AI. I used to manage the product team there for AI infrastructure, and been doing ML for about 7 to 8 years, mostly in the ML infrastructure side. Felt the need to start this company once generative AI, kind of the early research started coming out and the utility around it. Just being in the AI space, when you catch that glimmer of how much potential new technology has, it really kind of builds the motivation to start a company up. And so started the company about 2.5 years ago, saw how AI is done at some of the largest tech companies and bringing, sorry, I was just looking at the comment. Just please don't drive while on the meeting. And bringing some of the research and some of the ideas that we've had at these large companies into the startup space and making it more widely accessible. And so to start off with, I'm going to talk a little bit about what makes agents and MCP so unique, and why is it 2025 kind of the important year for these agents. And so first we'll talk about, agents in the tech stack and why 2025 is a big year for agents. Then we'll talk about pushing MCP to the limits. I don't know how many people here are familiar with Model Context Protocol, and so I can give a quick high-level overview of MCP and why it's so exciting, and then talk about how it fits into the agentic world. And then I'll talk a little bit of how we think about agents, which does tend to differ a bit from other people. And so I'll give kind of our flavor and our insights into what agents are like. So 2025 is the year of agents because more of these agents are hitting production and offering really high ROI. Up until now, a lot of these use cases, and I'm sure people have seen the MIT report that said, was it 95% of generative AI POCs don't make it into production? Is that the right stat? I think that's right. And that is a pretty large number. But what we're also seeing is there are some really core workflows that have been enabled by generative AI that has gone into everybody's day-to-day. And so when you think about Cursor, Claude Code, when you think about people using deep research, people using these systems day in and day out, we're starting to find that generative AI use case and products have started to really build behaviors towards people's day-to-day activities, as well as their workflows at work and their business workflows. Oh, is there a question? Or someone's mic on? Oh, okay. And some of these use cases that you also see is like deep research, which is one of the core reasons why we've done this deep finance research use case. And so with deep research, you've probably seen it within ChatGPT, where you can click the little telescope icon, and what it'll do is kick off a long-running research job, maybe 10 minutes, 15 minutes, where it'll look to identify some information that you've asked it for, and it'll collect as much information as possible with citations and return it back to you. And information retrieval is a really, really good use case where people are finding that deep research is playing an outsized impact. And what we're seeing is that's also true within certain verticals and domains such as finance. So for those of, I think probably most people here who've built agents before, this probably won't look too unfamiliar. There are two really important papers that came out towards the end of 2024. It was OpenAI's paper on how to build agents for production, and then it was Anthropic's paper for how to build agents. And both key themes that both of these had was using a simplified architecture as the right approach. As a lot of the frameworks that were coming out at that time introduced a lot more complexity. Both of the model providers, when they were interacting with businesses, are finding that the simpler the architecture, the higher chance of success. And it makes a lot of sense, because a big part of agents is because LLMs adds this variable of uncertainty and not really sure exactly what behavior you're going to get. The simpler the architecture, the much higher chance you have of building something that'll actually work, and the better you can modify its behavior. And so the core primitive, at least in Anthropic's paper, is called an augmented LLM. And that augmented LLM is when you make an LLM call, it has access to data through memory. It has access to getting more data through retrieval, and then it has access to tool calls, and it does a certain output. This is the fundamental building block to building agents. The next thing they talk about is the parallel workflow, which is from a single call, can you call 3 different LLMs, maybe the same LLM 3 times, and aggregate all that information together. So it's a fan in and then a fan, or a fan out, then a fan in. And then the last one, which is the part that we're going to double click in, is the orchestrator workflow. And the orchestrator workflow is really, really unique, where you actually have an orchestrator, which is typically an LLM, that generates a plan and assigns them to sub-agents. And from those sub-agents, each agent will execute, and then it'll aggregate and synthesize the results together. And this is something that has shown that you don't need a monolithic AI framework anymore. Agents are now these apps that can orchestrate other LLMs. And once you enable it with MCP, it has access to tool calls, data, and resources. And so this orchestrator workflow is the fundamental building block for how this deep research and a lot of these deep research architectures are built. And so what if we were to take it even further, right? What if we take this orchestrator workflow, this primitive that was outlined in the Anthropic paper, and we take it even further? That's when you get that deep research architecture. So, sorry, just take a quick sip. So for complex queries for LLM struggles with these complex queries because the first step that they need to do is actually break down the complex queries into its individual components that need to be executed. And when you do let an LLM decide exactly what the plan is, you're starting to see a lot better performance. And this is also why you're starting to see a lot more of these model providers have longer running LLM calls, we're starting to do a lot more reflection as well as planning to understand what is the true intent and what is the complexity of the task at hand. It's no longer the days of question answer, right? It used to be, simple things like, tell me the Euclidean formula or something like that. It's question answer. Now it's getting to a lot more complex questions that require much more logic. And with that, you actually need to break down the logical steps into its individual pieces to execute. And so the queries are getting a lot more complex. So deep research will take these higher level order of query, complex query, break it down into smaller manageable subtasks. And we see a much better improvement in performance because of that. And we've open sourced a deep research AI agent for finance to demonstrate the value of orchestrating these agents. So I'll do a quick demo. So let me share my screen again. 1 second. I'm just gonna kind of show the my entire window. So hopefully there's no infinite. Oh, there is an infinite screen. I hope that's okay with folks. Let me first kick off. So this is the AI in finance application that we're working with the AI Alliance with. The thesis was, can we reapply deep research into the financial domain so that we can treat it as if it's getting a lot of financial information, 10Ks, 8Ks about companies, organizing that into a report and outputting as an Excel file. And let me just kick it off here. And so I don't know if I quickly showed, we put the stock ticker as meta, and then I have an output path where I want the actual Excel file to be written. And so the first step it actually does is it starts the planning phase. And in the planning phase, it's really deciding on what is the plan that needs to be run in order to successfully accomplish the task, which is a financial report about Meta based off of its previous earnings and information that it can gather. And one key part of this actually is, can people see my VS Code here? One key part of it is it's planning and verification. So you can see here. So what happens is the original LLM, ideally you have a really strong reasoning model for your LLM orchestrator, will develop a plan, and that plan is going to help decide on how it's going to execute on this financial research. And the way that you can make sure that the plans are done properly is actually add verification. And so this is the plan verification step, also built into our framework. We give it 10 attempts and say, since the LLM is generating a plan, we want to make sure that this plan is valid. And we feed the errors back into the LLM so that it can iterate on the plan to make sure that the plan is done correctly. And so here, it's on the 3rd attempt. It has 3 errors. And this is a part of where we're building a bit more deterministic behaviors around an LLM, where occasionally this will finish in 2, maybe you'll one-shot it. Other times it'll take 8 times for it to get a really good plan. For here, you see on the 4th attempt, it's built a plan that passes all its verification, and so it's continuing forward. And from here, you can see that it has a task queue, and that task queue is the to-do tasks. It's going to retrieve financial information from the past 3 financial fiscal quarters. It's going to collect company guidance on revenue, gather consensus snapshots, search for public bank quotes. And the key part with this is it is connected to MCP servers. And so for folks who are unfamiliar with MCP space, it is Model Context Protocol. It is an open source protocol from Anthropic that is widely accepted as the common protocol for how LLMs interact with tools and different services. And so within our framework, which is called MCP Agent, we allow you to connect to many different MCP servers so that in this deep research task, it can connect to external services to fetch the information that's needed. And so for here, this is actually Yahoo Finance's MCP server, a financial data sets MCP server, the Exa Search MCP server, as well as the file system so it can write files, as well as the fetch, which is it can fetch from HTML, or it can fetch different web pages. And then the last one, Excel, is at the very end. Once it finalizes the entire report, it'll write it to an Excel file. And so you can see here, there's a few things, which is it has the task queue of how it's running about things. It also will reflect and try to understand if the actual queue at hand is the right thing to perform or whether it needs to revise its plan. It has memory. And so as it's going upon its research, it needs to collect the information, at least the relevant information for the final task at hand, which is the financial research about Meta. It has budget. I'll talk a little bit about the importance of budget. It has policies, which is like how many failures does it have? And this is particularly important because there are deep research and deep orchestration use cases where it will be bound where it cannot succeed. And if it cannot succeed a number of times, you do not want it to run for X number of minutes or spend 500,000 tokens. You want to make sure that if it cannot go any further, that it stops and it comes back to the user asking it for more information, or it needs something fixed in the architecture. And then the objective here, and this kind of shows you the known iterations it has, if it needs to replan the queue that it's running on, and the amount of time that it's spent on this. And so each part of the components of what makes this deep research architecture, I will dive into in the slides. And then just quickly showing the code a bit before we dive into it. It's actually quite short. This here is mostly just the terminal UI that you're looking at. The actual code for running it is right here, which is we create this MCP application called Finance Deep Research. We attach it the available servers, fetch, file system, as well as the Yahoo Finance financial data sets. We tell it some of our configurations. So you should parallelize as much as possible. You should have a max number of retries as 5. You should replan at most 2 times and then 25 iterations. And then budget. You don't want this to run forever. You don't want it to run and consume millions of tokens from OpenAI or any other model provider. And so providing budgets. And then once you have the orchestrator set up, all you do is give it your task, which is this prompt I have in this markdown file. And then you just run it, and that's it. So right here, which is generate the string, which is that prompt I passed, and then it's executing all of this. Amazing. So I'll let that run, and we'll go back to the slides, and I can kind of double back to it afterwards. Cool. Okay, let me share my slides again. Amazing. Okay, can people see my slides again? Okay, got some thumbs up, perfect. Okay, so at a very high level, how does it all work, right? It seems like magic. There's a lot of LLM calls. How is it actually doing this? So it begins with the user objective at the top, and that user objective is the user objective at the front is the objective of what you want to accomplish. And what you want to accomplish is, what do you want to accomplish with this financial research, which is I want to have the financial data for a certain stock company, and I want it for X number of fiscal periods or whatever the objective is. And the key thing to note about this objective is most of the time when people actually ask questions to any type of deep research or even any type of chat-based experience, it doesn't actually have all the details. This is actually very common. And this is why when you look at deep research for OpenAI's deep research, the first thing you'll always get is clarification questions, where the first pass that it goes through is hits an LLM, and the LLM will identify gaps in your questions or your prompts that need further clarification for it to execute. From there, it breaks down the objective into a concrete list of plans. The first thing we tried was to do sequential planning, which was take the objective, what is the first step that you should execute? And then from there, what is the second step, third step, fourth step? What we learned is when you actually build out the entire plan out front, the model performance and the overall research performance is significantly better. One by one execution, it has a hard time getting out of local minimas and gaps in where it's unable to go any further because it's kind of planned itself into a corner, while having a much broader view of what the plan is. It executes at a much better performance. Next, it goes into the execution task, which is it'll build a sub agent, and that sub agent will execute that single step within the plan. From there, it'll extract the data, especially within the deep research side. It'll extract the data, whether it's from HTML, whether it's from a MCP server that provides financial data, whether it is from another data source, whether it's a task that actually builds upon another task. So for example, if the first task is just do a Excel search to find other links, and then the second task is the fetch file server to extract information from an HTML page. Once that information is extracted, it's put into memory. And I'll talk a little bit more about memory management and how memory management should be done. And there's a lot of room for improvements in memory management. And so I'll talk about where some of the gaps are still. Once it has all the information extracted into memory, then what you actually do is a reflection stage. I wonder if we can, so I'm getting some questions while I'm presenting. Maybe it's worthwhile to just have the back and forth if it's useful for folks. What do people think? Do people want the Q&A at the end, or do people want me to answer questions in between?
If you want to answer questions in between, go ahead.
Yeah, okay.
Yeah.
I'm getting a mix.
Just be be judicious. If you want me to moderate them for you, I can.
Yeah. Maybe you can do that, Dave. If there's any like burning questions that you see where you're like, oh, this is something that we should probably answer right now, you should just interrupt me. I can't really see it on my screen, and so I just see like a pop-up and a quick 1 second for a question. So
yeah, no problem. I'll interrupt you if there's something really good, and I'll make sure to do it in a timely way.
Okay, perfect, amazing. Thank you, Dave. So where was I? So objective completion, which is asking an LLM whether it has all the information to successfully create and synthesize the results that is needed for the original higher level objective. And then the next one is checking policy. And so the checking policy is if it completes a task as well as all the requirements of it. If not, it needs to do a replan where it's not actually correct, and it needs to replan to create a new plan to execute. What makes deep research well suited to handle complex finance tasks, and what are the pieces around it? So these are 4 of the core components that we found as we went along. We started first with a simple orchestrator architecture. That one really broke down because having users or people to identify exactly what the sub-agents needed to be to accomplish the task yielded very low success. It was partially because as people were defining what the sub-agents needed to be, there were always gaps in responsibilities and tasks to be accomplished that made the actual deep research performance worse. And so what we found was a few things. We found that if you dynamically created sub-agents based off of an LLM, it performed a lot better. Next is memory and knowledge management. I'll actually go left, right? So memory and knowledge management, as it's going across the planning stage, it's keeping memory of exactly what it's executed before. It's keeping track of where it is in the to-do queue. It is keeping track of snippets of important information that is collected over time. It is also making sure that it can manage it properly so that it can compress it, compact it as it moves along. Second is the FIFO to-do queue, which is a first in, first out to-do queue. This is fairly common. You probably see it within Claude Code and other systems, which is how does it actually manage the to-do queue? I'll talk a little bit more about it in the next few slides. I talked about dynamic sub-agents. And last but not least is that budget management, which I'll talk about as well, which is pretty important. Okay. So memory and knowledge. Memory is extremely important for these agents, and it is more important for this finance deep research. So what you find within this memory and knowledge management is as it traverses these data sources, it's collecting quite a lot of information about the research task at hand. And it's collecting so much information that actually, if you don't actually do any type of processing of the data, you actually will run out of context length, context size. So it will easily surpass 10 million plus tokens. And so as you're traversing the data and collecting knowledge information, what you're actively doing is starting to reduce the information to what is valuable and what isn't. For example, The fetch MCP server collects the HTML data from a web page. Most of the HTML data is actually not fairly useful. And so what you have to do is strip out all the unnecessary things and only keep the information that is useful for memory management as it goes along. Even then, exceeding the memory management is quite common. And if you find that the memory management is reaching the limits, you have to introduce some type of compaction. And compaction is some strategy for how you're able to decipher what is the highest or most valuable information that you've collected and reduce the other pieces of information. If you can reduce the amount of words that you use to represent that memory or knowledge is also really important. And a more advanced form that we haven't gone towards of memory and knowledge management is to persist it in some type of knowledge graph or data store and only retrieve the information that's relevant. With that introduces a lot more complexity, which is the actual evaluation stage of whether it decides it's done enough research to successfully respond to the question at hand gets a lot more difficult, because what it'll need to do is it'll need to do some type of knowledge graph traversal, or it'll need to do some type of semantic similarity from any RAG system, collect as much information as possible, identify whether it has enough information to answer the question properly. And so memory and knowledge is an area that can use a lot of research and development. And I know there's probably quite a few folks here who are already researching in memory and knowledge. And I think that's a really good opportunity to collaborate. Adam, who's also part of our working group, also is in the memory and knowledge space. And so definitely a lot of opportunities for improvement within the memory and knowledge space within this finance research app. Next is a to-do queue. So as I mentioned, the to-do queue you see it quite often in Claude Code for people using Claude Code. It is that scratch pad that it uses for, here's the steps I'm going to execute to build you X, Y, and Z feature, to debug X, Y, and Z. It's also used within Cursor. It is used within most systems to identify some small piece of short-term memory of here's the task that I need to accomplish. Key things about it is as it's accomplishing a task, the LLMs will reflect and identify whether the accomplished subtask was done or not. And if not, it can actually create new tasks. You see this quite often also in Claude Code when it tries to do a bash execution and it hits an error, and it'll revise its plan or add additional steps to the plan of what it might have made a mistake on, reflect upon it, add the new subtasks, and then continue on. This is at the heart of the orchestration, and making sure that this is a dynamic data structure so that it's constantly being updated is quite important. Making sure that this is actively tracked is quite important. And I do know that there is research being done, especially in the industry, on what models are best for determining what plans need to be done, that is tracked within the to-do queue. And it's a lot of improvements where if you have enough data of exactly how complex tasks break down into subtasks, you can actually use that to fine-tune a model that can plan much better than currently what the models are able to do. We found that any of the reasoning models, whether it's Opus, whether it's the GPT reasoning models, do a lot better than the non-reasoning models, which make a lot of sense. Because underneath the hood, these are also breaking down the task and understanding what needs to be done. Third, dynamic subagents. And as I mentioned before, having people predefine the agents that need to be used to accomplish the task performed a lot worse. And so what we found is people can always specify a few agents, but in the end, letting an LLM decide what subagents to need works a lot better. And the biggest reason why this is the case is because when it's executing, the LLM is deciding exactly what tools it needs to solve the problem. And for people to preemptively or ahead of time know exactly the agents that are needed to accomplish a task is quite difficult to do. And so what we found is letting the LLM decide is much better. And so the LLM will naturally decide what subagents it needs, what information it needs to connect to, so which MCP service it can connect to. It'll also decide on what the prompt is, and LLMs are naturally quite good at prompting prompting and providing prompts for agents. And that's been quite commonly known in research across the industry. And so the financial deep research agent, here are just a few of the sub-agents that it creates on a single run. Obviously, different runs have different agents that it creates. But for the financial deep research one that I just ran on Meta, it created a 10K fetcher with the role of specializing SEC filings. It created a financial filing fetcher, which is the agent will connect to the designated Yahoo Finance server to fetch the most recent 10Q filings. Investor relations fetcher, access to investor relations server to retrieve the latest company guidance. And it just creates a fleet of agents, temporary sub-agents that it uses to accomplish the task at hand. Amazing. Most importantly, budget management. So this deep research agent and other deep orchestrator agents consume a lot of tokens. You'll find that it's easy to consume 10 million tokens. It's easy to have it to run 10, 20, 30 minutes. And what you need to balance, and what is commonly used to balance, is how do you actually know when it's complete? There are a lot of tasks, such as research tasks, that it won't ever complete. So for example, if I gave the prompt of get me all the financial information about Meta, it can keep researching for a prolonged period of time. And it's kind of arbitrary on when the research is done. It can always find more information. It can always find another CEO quote. It can always keep diving into the history of Facebook to get as much information as possible. But when do you actually call it as it's done? And this can happen when the objective isn't fully complete and it has consumed enough resources that you're saying that it is good enough and you can just synthesize the results. And so in terms of budget management, there is your tokens, cost, and time. And tokens and cost are correlated. And what you're going to find is you want to set a limit for how much you're willing to spend on a sit call. And the cost can blow up really, really fast. And so the recommendation is identifying what's the budget that you want for one of these research calls and setting it early. Usually start with a smaller budget as you're developing and testing. And then as you are doing more serious research use cases, you can always increase the budget that you want to run. And so budget management is much more crucial because it is at times an arbitrary completion qualification, which is you're giving a user objective on there might not be the perfect answer, and that's okay. And setting a limit for how much research should be done is absolutely crucial. And within the actual MCP agent code, what we do is once the budget is hit, we move into the synthesize phase. And so we use whatever information is currently available at that time, synthesize the final result, and give the best result. And having that type of emergency breakout path is important for any deep research, because the worst experience that users can have is it hits some type of budget limit, and it doesn't respond because it failed out. That means that individual wasted a few dollars, maybe more so, and they actually have nothing to show for it. And so having an emergency breakout path is quite important. Okay, so putting it all together, there is the understanding side of it, which is your deep research, understanding intent, breaking down the query into multiple steps, identifying the right MCP server and tool calls to use, and building the plan for a complex query completion. The next step is the orchestration phase, which is it manages the multi-step process. It carries all the important context step by step, as well as previous history. It evaluates the subtasks to make sure that it's making progress on the plan that it's outlined, and then it reruns or replans as needed. And then synthesizing, which is taking all that information from all the subtasks, reviewing all that information that's been gathered, and then delivering a complete result. So the first thing that comes to mind usually after we present something like this is it feels like a lot to run on your laptop, and we completely agree with that. This deep research workflow, similar to other deep research workflows that you see with model providers, is it should most likely be run as an async workflow, which is these workflows can be paused and resumed. They should be able to wait on human feedback. These may fail, but can also be retried. And these can be triggered or scheduled similar to like a chat message or a webhook or a cron job that can kick off these type of workflows. And because of this, it should be represented as async workflows as opposed to anything that's more synchronous. And so MCP Agent, we actually use temporal in the background for this. And I think a lot of the large model providers are also using temporal as the underlying infrastructure for this, just because it has all the right capabilities that we see that's needed for executing something that runs 10 minutes, 20 minutes, 30 minutes, hours, even days. And having a reliable compute cluster that could run it is very, very useful. Temporal also is open source. I know within the AI Alliance, with the open source technologies, it's something that is good to bet on. And then a quick plug out for us is we actually built the cloud system that also uses temporal. And so from running it locally to what I just showed, deploying it into the cloud and executing on it works seamlessly, so that you can actually just take that entire architecture, deploy it into the cloud, and let it run for a long period of time, especially if you have these long-running workflows similar to that deep research agent. Cool. Amazing. So this is the QR code to the AI Alliance and Finance Example Lab, the one that LastMile AI and AI Alliance are collaborating on to answer complex financial queries. All the code is there, and so you can actually just check it out and see what's there. Let me also share my browser, and I can kind of just give you a quick overview of what's there. 1 second.
We do have plenty of questions, so let me know when you're ready.
Okay, sure. So the first one, just a high level, is the blog post we wrote with AI Alliance. We talk about what we found. This was actually our 3rd to 4th time rewriting it because as much science as there's a lot of art to building an orchestrator. Like small things such as like using XML tags or pseudo XML tags and prompting made a big impact. The idea of all this budget management, and it's not a defined architecture that's so well known. And so discovering it, we found extremely useful. We want to share our learnings as we went through it. And so please feel free to read the blog post just to know what we've learned, and happy to see if anyone can actually take this research further. And then
by the way, that blog post got picked up on Hacker News and got quite a good chat going on there.
Yep. So I think it was on the front page of Hacker News. A lot of interesting and good discussions on this architecture. And so that's kind of the simple, like this is actually, so I kind of showed the simple high level view of what it actually does. But when you get into the nitty gritty, it gets a lot more complex. And then this is the deep orchestrator. It's all open source, which is the underlying library we use to build it. It has a lot of inspiration from Anthropic's, how we built our multi-agent system, the sub-agents that it uses, citation, memory, all of that. Also recommend reading this as well for people who want to read more about it. And then all the codes here, so you can actually take a look at the code to see how it was built, how it's split out, and the pieces and components that went into it. And then this is the QR code that I showed, which is the AI in Finance Example App, which you can also use. You can fork off, and we're happy to take collaborators who want to join on this project. And yeah, this is MCP Agent Cloud. If you ever want to deploy it onto a platform, works seamlessly with MCP Agent. And so it's really, really easy to just deploy it onto a cloud-hosted infrastructure. And you can have your agents as MCP servers, which is really nice, which means Cloud Desktop, Cursor, any place that takes MCP servers, easily portable and connectable into those systems. Okay, we have about 15 minutes left, and so I can just open it up for any questions.
Yeah, there's a bunch of questions here. I'm going to start off with a simple one. It says, this is quite a while back, so maybe you answered it. In fact, maybe you've answered some of these. Just let me know if you've answered them. This is from Jacob. He says, what does it mean that the plan failed. Can you give some examples of failures?
Yeah. So plan verification. So the first step for plan verification is actually using an LLM to do reflection on it, which is based off of the plan that was generated. What is the confidence interval that it has that the plan will generate the results that we're looking for the original objective? The second part of the plan succeeding is what you'll find actually in the code is we do a lot of combination between what's using an LLM and what is written out as like basically code verification. So for example, if the LLM hallucinates and accidentally gets a MCP server that doesn't exist, then that is a plan failure. If it tries to call a model that doesn't exist, that's not within the default models that's provided, that's another failure. If the prompts that it's assigned for sub-agents also don't match the expected requirements, that's also a failure. And so throughout the entire orchestrator, in order to make it work reliably, each LLM call is it's basically layered together with actual syntactic and verification and verifying whether all the things that it calls upon, the resources, all of that are valid. And this is the only way that we found to prevent hallucinations from building up, which means that as it's making every LLM call, there is a suite of verifications that need to happen to make sure that the LLM and subsequent LLM calls aren't going off the rails. And the first easy one is like, Pydantic models, making sure that it's fitting the right model structure, the data structure is proper. Then a lot of checks afterwards just to make sure that it is not hallucinating anything that it cannot do. And that's kind of the plan verification. Great question.
Great. You may have answered this already again, but can you provide a deterministic plan is the question.
So the original framework without the deep orchestrator is deterministic planning. The problem with deterministic planning, and I think I've mentioned it towards after the question was asked, is we found that the performance is just so much worse. And part of it is as the LLM's executing, there are its plans on how it's executing and what it's missing versus what the developer or the original author thinks is the right plan. And all of those gaps of it not working together makes the performance really poor. And so what we found is letting an LLM, same way that if it's doing, let's say Claude Code, or it's doing any type of research tasks, you see actually quite often that it will try to unblock itself. And that's a really powerful behavior of LLMs, which is if it hits an issue, it will try to unblock. And the more deterministic plan you provide, the more you're limiting it from unblocking itself. And so generally we recommend allow the LLM to try to unblock itself, because if it's too rigid, the failure rates will be quite high. So yeah, that's my general recommendation.
Great. And here's a question from Ian. Which API provider do you use to scrape the internet for deep research?
API provider. Okay. I guess question for Ian is, are you thinking more of like a search engine or a fetch MCP server, or model provider?
I don't know if he's going to be able to. If you want it, Ian, you can unmute yourself or type real quick in the chat interface. But you might want to just choose one and answer it, because he may not be able to answer.
Yeah. So the MCP servers, we did Exa. Exa was quite good for search. And then fetch, which is a classic from your URL to fetching the HTML data. And then a few data sources that have really good financial data, which was the Yahoo Finance one, and the financial data sets. And the financial data sets, I believe, is using the Edgar APIs underneath to retrieve data. And already something that, I know Dave knows this because we're part of the same working group, is the better the data sources you provide, the better this application does by far. And so if anybody knows of good data sources we can use for finance, welcome aboard to our working group.
Yeah, we're always looking for more financial data. There seems to be no limit to how much more we need.
Yeah.
Here's another question from Jacob again. Okay, in essence, is it that after finishing each task, you are asking the LLM if the plan needs to be changed, updated, and if yes, it can even start from scratch? Is that that's a question mark?
Yeah, it's a really good question. So it's twofold. One is a full replan, which I think you caught saying.
Yeah, he asked later on. He asked later on, like, what is a replan if not changing the plan?
Yeah. So there's two things. One is a full replan, which is we limit it to 2 because it literally means that the path it has taken, there is no way to succeed, and so it needs to replan everything and start from scratch with the information of why it failed the first time, because we do not want it to repeat the failure. And then the second one is the small adjustments that it will make, which we don't really call full replan. That one is when it does a reflection on whether the task at hand was accomplished or not, and if it needs subsequent subtasks to accomplish the task. So it's basically adding in subtasks into the plan because it needs it to accomplish whatever it needs to do. So it's your original plan, you have tasks, subtasks, and then those can actually fold into more children tasks as well. Great question.
Okay. Okay, so this is a long one. I really want to grasp the machinery, and as we saw in one of the first slides, after the task is executed, the replan can happen. This need for replan will be triggered by the LLM, right? So my question is, can this replan decision wipe out all that has been done until now and start from scratch? I can imagine the LLM entered some rabbit hole. Okay, you just answered this question, I believe, but do you want to comment on that?
No, it's I think I answered that, which is, you can do a full, but it does need to have basically the postmortem of not do a replan and fall into the same trap. And so here's information of why it didn't work and continue onwards. And so you're completely right. It can go into a rabbit hole or a local minima of it will never be able to accomplish a task in any good quality. And so it needs to completely restart.
Got it. Okay. Okay, here's from Andres. He says, is this orchestrator free from hallucinations? And can this kind of orchestrator deal with timed decisions? For example, change behavior if after X minutes something doesn't get the desired result? I guess I think you kind of answered that one.
Ooh, that's a really good one. So the second part, which is time-based results, I think what you've described is a little bit more nuanced than what we have. What we currently have is like, here's the time allocation, 10 minutes. And once the 10 minutes is up, you have to brute force your way to get an answer because it's like you cannot respond with nothing. And so it will brute force its way with the whatever knowledge it's accumulated to answer it. What you're asking for is actually even more nuanced, which is like, it's almost like a 2-minute timer. And it's 2 minutes until 10. So like you need to work differently than how you're working before. And then the 10-minute one, we haven't gotten there yet, but that's easily extendable, which is a more nuanced flavor of like, you can casually research. And then when they get close to the end time, you have to kick it into next gear and like just go into what data you have, go deeper, and then get the results. Definitely extendable to the framework.
Here's a question from Carbo. He says, I think inputting the budget in the plan can help with reducing costs, and the LLM can optimize the resources to get better results. He says, are researchers considering that? Answer that however you want.
Are researchers considering, these 3 factors?
Yeah, I think is the LLM actually optimizing based on the budget?
No, the budget is completely separate. The LLM is not optimizing for the budget at hand. I'm trying to think of if the budget was provided as like would it naturally progress better? Hard to say. I mean, I think that's close to, there's like early research done on like you can make an LLM give better results if you describe its urgency. If you're just like, I absolutely need this versus can you get this? There are some like high level research that it does perform better here and there. And so it would kind of fall into a similar category. I don't know if I've ever seen anything that's ultra definitive there, and it's so tricky. Like the prompting parts are so tricky to get right, to be quite honest. Like even building this out, the prompting is where a lot of insights come from. So like seeing how the prompts are set up for a lot of these coding agents and stuff was really enlightening and semi-magical. I think a lot of us have CS backgrounds, and so everything is pretty deterministic there. And so programming in natural language and invoking emotions or like fake XML tags to get better performance seems wild to me. But yeah, so hard to say if we were to provide the budgets to the LLMs, if that would do better. But currently we don't. We basically just let the LLMs run. And one thing that's nice about it is one less variable to debug. Yeah, and so that's a big thing, debuggability. We have really, really verbose logs that help us debug step by step to know where things are going wrong. So identifying that entire memory context of what's collecting, whether certain passed, didn't pass, all of that, the prompts, what prompts are passed, all of it is really important. And yeah, extreme transparency is needed to make sure that these systems work.
Here's sort of a follow-up, I think. Are all of these activities like, creating a plan, deciding if replan is needed, if they're all done via the LLM, I suspect, yes, but doesn't this mean that these decisions are really LLM dependent, meaning that chaining a model can put things upside down?
Okay, I think Jacob's question is valid, which is like, let's say an LLM completion request results in a 85% accurate answer, and then you run it again, that's another 85%, you have compounding error rates, right? And so at some point it's like, it's pretty much garbage. It's like 0%, right? That's originally also how I thought about it, but something that's quite novel is the fact that there's these reflection states, and LM as a judge, which is you can actually find that performance can improve if you actually give it back to an LM and say, what's wrong with this? It's reminiscent of the old school GAN style architectures where you're actually pitting two models together. This time it's actually a reflection stage, which is like, how do you make this better? And then you pair that up with some of the more deterministic code-based validations, and you're starting to find yourself having decent performance. And the more that you actually start putting in these guardrails and these checks and balances throughout, you can actually see performance actually improve overall. And the part that's really exciting about it is this similar architecture is how a lot of these deep research agents are built, and the quality is actually quite good. And it's good enough where different banks you talk to, they're like, this is pretty good. It's getting close to what an analyst would do. And we think that there's a lot of potential here. And so I totally get the sense of it's like, LMs, 15% of the time they're wrong, chain enough of them, you're at 0%. But it's not compounding error rates, because you do have some different types of architectures, which is the reflection, the fan outs, all of that, which help reduce the error rates. It means that probably the report that you'll get is still like 90%, right? It's not like 100% as amazing, but it is pretty good. And then you add citations on top of it, and that's good enough where you'll save someone a huge amount of time, where they just need to do quick validation to make sure it's right, as opposed to getting all the data from scratch.
Great. Here's a question about search. How does Exa and Fetch compare to perhaps like Google's SERPer? Although maybe that's not specific to finance. Have you used all three of those, or do you have any experience with different ones?
Google's,
I guess there's one called SERPer. Google SERPer, is that like a Google search?
I I just did a Google Serper.
I don't know. I don't really see Google Serper either. Maybe that's
okay.
maybe that's a mistake.
So it looks like there is a SERP. So Google Search
SERP
API,
API.
SERP API. Maybe that's
yeah.
the one. Yeah.
Yeah.
I haven't tried it. I have used the early Google MCP servers, which not from Google, just community member who built it, where they're executing queries on Google. I think that the biggest bottleneck to Google, the search APIs, is nothing to do with quality of the search results. It's actually mostly due to like limiting and throttling. So Exa, Tavili, Brave Search, the Google Search API, like all of this they're all really good. I found that the biggest limiting factor is actually they all put in pretty rigorous throttling, and Exa was the most generous, and that works to any advantage because this deep research is making many calls, and so the more generous the free tier, the better. Yeah, so that's probably my decision making, and so the quality of results are all generally comparable because I don't think, yeah, the search results of whether something is in the first link, second link, third link, or as accurate and up to date is not really the most important thing for at least the deep research runs I've done, which are like financial reports. And most of the search engines' financial reports are all within the first page. Yeah, so it's mostly on like who's not going to throttle and who's not going to slow things down, because that would be by far the worst. So definitely view some that like a query per minute or something like that. And I was like, wow, this is not going to work.
All right, we are getting out of time here, but we just have a couple more questions. So if you don't mind sticking over,
Yeah, sure.
we can get, okay, great. So here's a good one. For someone new to MCP Agent, what are some good ways to contribute or collaborate? Where should you start?
Oh, yeah. We have tons of stuff. So like, I think the first place to start is just on, let me just share my screen. Yeah. So I think the first place to start after like just building a simple agent and maybe going to the basic agent is starting to look a little bit at different use cases. So what we're finding is the MCP protocol, or model context protocol, the spec is changing over time, and it's a lot for the better. So like elicitation, notifications, all these things, and they're all really powerful components to the model context protocol. And so those are great opportunities to collaborate, which is if there is something really cool in MCP that should be easily available to an agent, you can definitely bring it over. We're always happy to collaborate. The other one is use cases. If you have any really cool use cases, we're always happy to work with you on it and showcase the use cases. These are just a few of the ones that we have here, but there's a lot more interesting ones that are always coming out. So yeah, that's probably the best places to begin to collaborate. And yeah, feel free to reach out to me. We're always looking to collaborate with folks, so always happy to collaborate.
Great. Got a couple more here. Is there a way to ask the Orchestrator LLM to create the workflow code, compile, and run it and execute it without running it inside the hallucinating LLM decisions? I think that is that getting back to the deterministic question?
It's interesting, which is like, so the current architecture for a lot of deep researches leans very heavily towards LLMs. And the question that's made is it better to have an LLM come up with a high level plan, or is it better to have an LLM just write all the code and run that code? So I'm putting some serious thought behind this. My gut feeling is it is better to have the higher level order orchestration across LLMs than having it output code and executing code, because models still do well with coding one-shot things, but it will not do well with many iterations of it as it goes along. And I see this all the time, even with the best coding models, which means the chances of it getting stuck into some type of rabbit hole that needs it to redo all the code is probably quite high. And it also depends pretty heavily on making sure that the code snippets for all the authorization, everything to the other services is done. But there's an argument that you connect to the MCP, but if it's using MCP, MCP is designed for LLMs, so it has to use REST APIs. And if it's calling the REST API calls, then it needs to learn all the authentication and all the REST API calls for these other services you want to use. So it's a fair question to have. My intuition is telling me that based off of all the coding I've done, coding gen, all of it, having the higher level order of it, creating a plan and letting LLMs execute will yield much more successfully than having it write all the code from scratch. But yeah, that's my gut feel.
That's great. He says later on, he says, we created a language to describe conversations. So an orchestrator, a properly trained LLM, might create the code to run it. Anyway, I don't think that's a question. Just want to add that comment. All right, we got, oh gosh. Okay, folks, we can't take any more questions. But here's one. How will the plan be restricted by the context window?
Oh, that's a really good one. Okay, the plan is restricted by the context window quite dramatically. So this is actually very unique to finance deep research as opposed to regular deep research. The reason why is financial documents are massive. Like there's like a lot of the 10Ks don't even fit. And so you have like a lot of pagination and you have a lot of ripping out just the important information. So you're designing an architecture designed for lengthy pieces of content that needs to be put into a finite context window. And so it goes in pretty significantly for this deep research. And I imagine it's actually quite similar if you were building something similar within healthcare space or legal space, where the content and context of a single unit of knowledge is so large that you actually need to do some type of core pagination underneath. While general deep research, you could kind of get away with like, what's the best flights to X, Y, and Z, and it'll go to some website and just pull the flights. And it might be 100 lines, maybe 1,000 tokens, 10,000 tokens. But I've seen within the finance one really exceed into like the million plus. And so designing a plan for that is really important. I actually think, to a lot of people's point for this, the pagination logic should probably be not an agent that paginates. It's functionally a lot better to have it in code. And so if it retrieves data that's too long to process in a context window, it should have the code written there for pagination.
Oh, I'm mute. Okay, and that does it. We've got some people commenting, thank you, and nice presentation, interesting, great talk, all that kind of stuff. I'm going to put the link here to, you've got the link there to, sorry, where does that one take you? To the MCP agent, right?
Yes. Oh, let me put the deep research one. There you go.
Oh, it's okay. You can leave that one up. I just put the link in the chat to the deep research as well.
Okay.
By the way, are we changing, is Deep Orchestrator the underpinnings for the deep research? Is that how?
Yeah.
Okay,
yeah.
That's what I thought.
We're somewhere in between deep orchestrator, deep research, and then finance deep search.
Right.
So you're probably right one way or the other, Dave.
Yeah. Okay, great. Well, and for those of you who are in New York, there is a meetup happening next Tuesday.
Mm-hmm.
And I should actually get that link and post it here as well. I'll post it in just a second here. Here it is. Let's see, copy. Okay. Yeah, if you're in New York, here's the link to the event. It's on Tuesday. Thank you again, Andrew. That was really awesome. The questions are great too. So audience, attendees, community members, thank you so much for participating. It really makes it enjoyable. I feel like we always get these good talks, but then what makes it a great event is having really good questions. So thank you, everyone. And we look forward to having you back next week. I think we're almost done finalizing our talk for next week. The week after that, we have something that's called the it's called the Agent Lab UI, which is sort of a really experimental project we're working on in the AI Alliance. It's sort of one of our first projects for the Open Agent Lab. So hope you'll join us in 2 weeks for that. And then we'll have our topic for next week posted shortly, probably by tomorrow. All right. Thanks, everyone. Thanks, Andrew. We'll see you all later. Bye-bye.